In this video, we're going to be talking about force and stability. So in the force and stability, we've gone through and done problems 1 and 2, or 9A and 9B, and this is for the traffic cone. With the traffic cone, it's a 28-inch traffic cone. There's a 3-pound horizontal force at the top, and the width of the base is 14, with the center of gravity being 7 applied in the center. So taking a look at this, we can go through and figure out what the minimum force, the minimum weight of the cone needs to be. But we don't know the volume. And this cone is a little bit more of a complex shape. We could do a revolve, which we're not going to do in this video. I think there's an easier way to do it with a more advanced extrude feature. So we're going to start with this 12-inch circle, and we're going to extrude this circle up, but instead of going straight up as a cylinder, we're going to taper it in to kind of form this cone shape. And then later we'll come back with a shell for the 0.25-inch thickness. And I want to point out this is 28 inches tall, but 1 inch of that is the bottom. And so my extrude is not going to be the 28. It's going to be the 28 minus the inch for the bottom. So it's only going to be 27. So let's go over to Inventor. I'm going to start a sketch on this plane here and put my circle in the center, and I'm going to make it 12 inches. Then when I go to extrude, again, I said I was going to make that 28 minus 1. Okay, or you could just type in 27. The other part, it's kind of hard to do with this. If you know what you're doing, you could click on the arrow and just, or not the arrow, but the dot. Let me show you that again. You finish your sketch, go to extrude. This dot right here, you can actually grab and click on it. But the easier way to do it is to open up your this box here. And when you go to the More tab, notice how the arrows change colors. So when we go to More, we want to put in -9 is the number, because 90 minus 9 is going to give us that 81-degree taper. And again, we don't know the dimension at the top. If we did, we could have also done this with a loft tool. So the -9 is the taper. The shape is a 27 for the extrude. You have to do this first, okay? Because the next thing we're going to do is the shell, and we're going to make it 0.25 of a wall thickness. And I'm going to take off the bottom. Depending on how you look at the drawing, they kind of show it as a dotted line on the top, meaning that there is a top there, but when you look at the picture, it's kind of hard to tell if there's a top there or not. So either way, it's not going to make a huge difference if you remove the top. Now the reason we have to do that first is this is 1/4 inch thick. When we go to look at the bottom of the cone, we're just going to take a 14-inch rectangle with some rounded corners and extrude that down 1 inch. But if we did the bottom first and then the cone to shell this, then we'd also be shelling the bottom at 1/4 inch. And we want a little bit more solid thickness there to lower the center of gravity a little bit. So let's go and get the bottom part of it on 14 with 1 inch fillets. And then we can also apply a material. The material that we're going to apply is going to be rubber. So I'm starting a new sketch on the bottom, and I'm going to use my 2-point center rectangle. I love this rectangle when we're doing things that have center points. And I'm going to use my numbers to type in 14 tab 14, hit enter, grab my fillet tool, set it to 1, and if you click on the corners, both corners, there we go. And I'm going to extrude this. Oops, I don't want this thing to be solid. There's one thing I forgot to do, and I can either use the circle tool to redraw my circle, or since it's already there, I can use the project tool and project that geometry. And now when I go to extrude, it's only going to extrude the outside part 1 inch. And notice how this is solid. I just want to show you, don't do this, okay? Don't do this. But if I did the shell tool afterwards at a 1/4 inch, see how this is actually becoming hollow on the inside? And that's what would happen if you did or tried to hollow out the traffic cone after you did the base. Okay, so all this stuff, we would lose all of that volume, but that's solid right now. I'm just going to show you a side view. If I go to my half section, okay, the traffic cone is solid in all of this stuff down here. The darker gray, all of that is solid. And so that's what the traffic cone looks like. Okay. Don't forget to change your material to rubber. And it's going to be kind of dark, but if you wanted to get fancy, you could come over to the paintbrush and take this and switch it to a nice orange color as well. Just take the whole thing and make it orange. Hit the plus. Maybe I want to click on the bottom part, this bottom extrusion, and set that part to be black. There you go. So now I have a traffic cone made of rubber. Right click on your part, go to Eye Properties, Physical, and then when you hit the update button, then it will tell you your mass, area, and volume. Take a look at the density. What is the density that you calculated it needs to be? Okay. What is the minimum cone weight? You can calculate that. What is the minimum density? Is rubber a good density? If not, then you have to answer the last question. Well, you got to answer it either way. What material would you use to manufacture the cone? If the density of rubber isn't enough, what could you do to make the traffic cone heavier? And does that need to be applied everywhere or just at maybe the base of the traffic cone? Keep in mind, traffic cones are normally rubber or plastic, so that if a car hits them, it's not going to, destroy the car or leave marks. So also, people have to carry lots of traffic cones, like 4 or 5 traffic cones, and as they're setting up an intersection. And so if the traffic cone weighs more than 10 pounds, that's kind of really heavy for a traffic cone. So just some things to keep in mind that aren't really talked about. If you have any questions, please don't hesitate to ask. Thanks for watching.